Good evening, class. At the moment, I'm going to review the learning target and the key points of today's lesson for Math 113 for January the 5th, 2018. The first video of 2018. Many more to come. Our learning target today was I can graph the parent functions of sine and cosine. Yes, this is going to be the shortened version from today's lesson, but it's going to hit all the key points that you need to know. Okay, let's look at the sine function first. Y equals sine theta. It can be written like that. Let me focus in some. Or it can be written as y equals sine x. Theta and x are both variables. They use theta a lot when you're talking about angles and stuff, like 90 degrees or pi over 2. You see theta a lot. But if you see either one of these, it's like x. So do not get that confused, okay? Do not let that throw you off. Alright, I want to graph this function here, the parent function y equals sine theta. In this unit, we're going to graph sine many different ways, but this is where it originates from, is this parent function. We're familiar with parent functions. So, y equals sine theta. I'm going to draw me a little diagram here to hit the major points. You know over here, if we can went around the unit circle, this is 0 degrees. This is 90, or pi over 2. I'm going to say pi over 2. Pi, 3 pi over 2. You could have 90, it's fine. And then this is back at 2 pi. Now let's look at our ordered pairs. This is 1, 0 associated with this point. 0, 1, negative 1, 0, and 0, negative 1. Okay? I'm going to make a table of values. And the table of values are dealing with the major points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I was to substitute each of these in for theta or x, sine of 0, this is why we do trig Tuesday, every Tuesday, because you got to know these values. Sine of 0, remember sine is associated with the y. The y value is 0 here, so that would be 0. Pi over 2, sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. Okay? These are my x-coordinate zeros here. I'm going to make pi over 2 here. Pi, 3 pi over 2, and 2 pi. My y value, the highest y value is 1. The lowest is negative 1. And I'm going to graph 0, 0, pi over 2 up to 1, pi 0, 3 pi over 2 down to negative 1, and then 2 pi. And I'm going to connect the dots. That is the graph of the parent function of y equals sine theta. You should be able to graph for me y equals sine theta using the major points at any given time I may ask for them. Now, and we're going to come back and talk about the characteristics of this graph in a minute, but I want you to go and graph y equals cosine as well, so we can compare the two. So y equals cosine theta, or like I said, it could be y equals cosine x. Either way, that's the parent function. Make a table of the major points. 0, pi over 2, pi, 3 pi over 2, back home at 2 pi. You want the cosine of 0. Remember, the cosine is the x value. The x value is 1. Cosine of pi over 2 is 0. Pi is negative 1. Cosine of 3 pi over 2 is 0. And 2 pi is 1. Graph it just like our sine. Let's go graph this. Let's graph this. 0 and 1. We start up here. And it's more of a curve, not a straight V, okay? It's a curve. And we've graphed the parent functions of y equals sine theta and y equals cosine theta. Okay? You should be able to graph these into, these are my major points on the unit circle. Now today in class we did all the points, but I just need you to be able to do the major points. And know the shape of the graph. Notice that the sine starts at the origin, cosine starts up here at 1. Big difference, but we need to know. Now, guys, we've got to go over some vocabulary that you need to know. This is the stuff that's on your quiz tomorrow. You need to be familiar with. Both the sine and cosine graphs are known as periodic functions. Periodic functions. I'm going to write that word down. Periodic functions. What are periodic functions? Well, the sine and cosine graphs are known as periodic functions because these graphs keep going and going and going and going. They keep going and going. And this repeat is called cycling, okay? But they are known as periodic functions because they repeat a pattern of y values at regular intervals. The next vocabulary you need to know is cycle. This is one complete revolution, one complete pattern. Because what happens is this thing keeps going and going like this, guys. It keeps going forever and forever. This just represents one complete pattern. This is one pattern. So a cycle is one complete pattern. This is one cycle of the cosine graph. It keeps going. So if I ask you guys why are sine and cosine functions periodic, it's because they keep cycling. They are cycling. They keep cycling. And if I ask you what is one complete pattern, you need to know that it's cycle. Another vocabulary word that you need to be familiar with is amplitude. I call that the height of the graph, but the more mathematical part it deals with is the max or the min, the absolute value of the max min. For example, in this graph right here, the height of it goes up to 1. The absolute value of 1 is 1. The minimum is negative 1. The absolute value of negative 1 is 1. So the amplitude is really like the height of the graph. The definition is mathematical is half the distance between the max and min values. And the last vocabulary word that you need to know is period. That is the distance it takes to complete one cycle. Those are very important vocabulary words. So if I ask you tomorrow, what is one complete pattern that is cycle? What refers to the height of the graph? Amplitude. Think of it this way. You turn the amp up, it gets louder, the height. What refers to the distance it takes to complete one cycle? Period. Why are sine and cosine functions referred to as periodic function? It's because they continue to cycle. So, let's look at these two, the sine and cosine, parent functions. Let's look at the domain first. The domain. These things keep going and going, so your domain will be all real numbers for both of them. Range does deal with amplitude. How low does it go? It goes down to -1. How high does it go? To 1. Bracket, -1 to 1. And that's also same thing for cosine there, from -1 to 1. So they do both, the parent functions share the same domain and range. You need to know that. Now let's look at amplitude. If I look at this graph, the highest it goes is 1, absolute value 1 is 1. So the amp, I believe it goes AMP is 1. Also down here, that is 1 as well for the cosine. Let it focus in. Sorry about that. The amp is 1 for both of them as well. Remember, the period is the distance it takes to complete one cycle. Okay, if I'm starting here from 0 and I went from 2 pi to complete one cycle, if I start at 0 and go to 2 pi, my distance is 2 pi. So my period is 2 pi. Same thing here. I started at 0 on the x, I go to 2 pi. It took me a 2 pi distance to complete one cycle. So if you notice, the domain, range, amplitude, and period for both the sine and cosine are the same. One thing that I need you to know is, notice this. Like I said, the sine starts at the origin. Very important. The cosine starts at the amplitude. You need to know that. Very important questions. Now, today we talked about, we used to study stuff that had end behavior, you know, where the ends go in here. Let's talk about the end behavior of these two. These things keep going and going and going, bouncing up and down. These keep bouncing up and down. These two have no end behavior because they are oscillating. And what oscillation means, they're bouncing up and down like music waves. There's no end behavior. End behavior does not exist on these two functions. It's just something that you need to know as well. But you just need to listen to, review these vocabulary words. Know that sine and cosine are periodic function because they continue to cycle. Cycle is one complete pattern. Amplitude refers to the height. Period is the distance it takes to complete one cycle. The domain for both of these are all real numbers because they continue to go. Range is -1, 1 because they bounce between 1 and -1. The amp is 1, the height, and it takes a period of 2 pi distance to make one cycle on both these. You need to know all these vocabulary words and be able to draw the parent functions at any given day, possibly on your pop quiz tomorrow, using the main points from the unit circle. Okay? So please, I hope this helps you, and I will see you tomorrow.